Hi guys. Today we're going to go over question 3 from the 2015 exam in paper 1. Okay, so we have a quadratic fx equals minus x squared plus 12x minus 27. And of course we try and identify important information. Okay, so straight away, before we read part A, let's just write our function. Fx equals minus x squared plus 12x minus 27. Okay, so from part A, okay, so we want to complete the table below the values of fx when x takes the values given in the table, 3, 4, 3 all the way up to 9. Okay, well, this is simple. This is just as simple as just inserting that value of x. So for the table x equals 5, well, what does that equal? Well, f of 5 equals minus 5 squared plus 12 by 5 minus 27. And this equals minus 25 plus 60 minus 27 is 8. Okay. Now f of 6 is, again, just plug in 6 into the function. Minus 6 squared plus 12 by 6 minus 27 is minus 36 plus 72 minus 27, which I think is 9. Yeah, equals 9. So, plug that in. Okay, now what about for 8? Well, what is f of 8? Very simple, just plug it into the function. And we'll get minus 64 plus 96 minus 27 equals 4. Is that right? No, yeah, it is. Equals 5. So what you'll notice is this is a quadratic, so it's exhibiting symmetry. So if you notice, we have 0, 5, 8, 9, 8, 5. So you might be able to guess that f of 9 will be 0, but let's just check. Minus 9 squared plus 12 by 9 minus 27, which is in fact 0. And if you look at a quadratic, then it does look something like so it is symmetric. So it does sort of make sense why we get something like this. But this, that's very, very nice marks. Okay, I just had to give myself a little bit of room to do the rest of the question. Alright, so on to part 2. Use the table and the trapezoidal rule to find the approximate area of the region bounded by the graph of f and the x-axis. Okay, so straight away, before we even read the second half of that question, we see trapezoidal rule and table 1. Okay, well, what is the trapezoidal rule? Well, let's just write that out. Trapezoidal rule, and we can just go to the log tables and it is that the area, which is what we're looking for, is approximately equal to h over 2 by y1 plus yn plus 2 times y2 plus all the way up to yn minus 1. Okay, well, what is h? What are all these y's? Well, if we look at if we have a function, and let's say it looks something like this, and we have its values at all these equal points, and we want to find the area under the graph between let's say A and B. So h is just this bandwidth, just from here to here, from here to here. So this is h, this is h. Okay, and so what are our y1s? Well, this height here is our y1. So it's the height at each of the x's that we know. Sorry, that should be straight. So the height here would be y2, the height here would be y3, these should be straight lines, and so on and so forth, and then this would be yn. Okay, so that's just how to visualize what the trapezoidal rule would be doing. So in this case, the distances between the x's is just 1, 3 to 4, 4 to 5, so h equals 1. And the y1s are the values in the table. So y1 and yn, the first and last value that we have, which would be here and here, those are both 0. So let's just plug in the formula. A approximately equals, well, we can just y1 equals 0, yn equals, well, which yn equals 0, y2, n just being the last one. There's, how many of these are there? 1, 2, 3, 4, there's 7, but just say it's n. y2 equals 5, y3 equals 8, y4 equals 9, y5 equals 8, and y6 equals 5. Okay, so A is approximately 1 over 2, h over 2, by y1 plus yn, which are both 0, so we can just ignore those. We can just multiply by 2, and then y2 all the way up to y6. So 5 plus 8 plus 9 plus 8 plus 5. So if we notice, these two will cancel each other out. So we'll just have 5 plus 8 plus 9 plus 8 plus 5, which is 10 plus 16 plus 9 is 35. Okay, so yeah, it's approximately 35 using the trapezoidal rule. And it's just as simple as that. So the important thing here is to be immediately use the formula and try to identify what is, I think that it shows in the log tables what h, helps you visualize what h is, what all the y's are, and then it's just as simple as just plugging in the formula. Alright, so now we're actually going to find the area under the curve. So if we read the question here, find the integral. I suppose everything's important here when it's this small. Find the integral of f of x between 3 and 9. Okay, so we're looking for it. Let's just write out the question in maths form. The integral from 3 to 9 of f of x, and f of x is minus x squared minus x squared plus 12x minus 27 dx. Okay. Well, we can use our log tables and go to the integration section, and we see that the integral of x to the n is x to the n plus 1 over n plus 1. Because if we remember, the integral is sort of like the antiderivative. So we've got to think the derivative of what would be x to the n. And if we see immediately that if we differentiate this thing, then we would get x to the n, reduce the power by 1, and then multiply by the power over n plus 1 multiplied by n plus 1, which would be just x to the n, because the n plus 1s would cancel. So we have the integral of, so that we have this rule, okay? So if we use this, then we get, if we integrate one step at a time, so let's first integrate this part, then we get minus x to the 2 becomes x to the 2 plus 1, 3 over 2 plus 1 is 3. And then if we do with 12x plus 12, and x is the same as x to the 1, so this becomes x to the 2, 1 plus 1, over 1 plus 1 is 2. And then minus 27, and whenever you have a constant, it just becomes x times that constant, minus 27x. Because if we think about it, the integral of 27x would just be 27. So then we have all this evaluated between 9 and 3. And what that means is we sub in 9, so we sub in 9 to this expression, minus 9 cubed over 3, plus 12 over 2 is just 6, 9 squared, minus 27 by 9, minus 3 into this expression. So again, we have minus 3 cubed over 3 plus 6 by 3 squared minus 27. Sorry, that looks crap. Okay. If we carefully put this in to our calculator, we get that this whole thing equals 36, which sounds about right because our approximation was that it was 35. So, seems right. Okay, so use your answers above to find the percentage error in your approximation of the error. Actually, let's just put our answer in. So our answer here was 35. Our answers here was 36. And use your answers above to find the percentage area in your approximation of the area. Correct to 1 decimal place. Okay, so what's important here? We need to find the percentage error in our approximation of the area. Correct to 1 decimal place. Okay, so what's our formula for error? Well, our formula for error is, for an approximation, would be approximation minus the true error, the true value, sorry, all over the true value. All right, so it might be hard to remember, is it approximation minus true over true, or approximation minus true over approximation? And if you think about it, let's say if it was over approximation, well, that wouldn't really make sense, because we're not really comparing it to, we'd be comparing the difference to something that's wrong. And so it doesn't really make sense for the denominator to be the approximation. And so, just importantly, it's always the magnitude of this. It doesn't really make sense to have a minus percentage error. So in this case, we have the approximation is 35 minus the true is 36 all over the true, which is 36. So this is just 1 over 36. And so what is 1 over 36? 1 over 36 is 2.77%. So that rounds up to 2.8%, because it asks us to round to 1 decimal place. And it's just as simple as that for this one. This seemed to be a nice question. Using your log tables to do the integration, using your log tables for the trapezoidal rule, and just remembering the formula for percentage error.